Hello and welcome to the LAN Championship Showdown Technical Deep Dive. My name is JPEG. My role on this project was stream integration and design. People from the Splatoon scene might know me as the former low-ink head TO. I have left that position in June of 2023 to pursue creating better and better live streams for Splatoon and other live streams. In the Splatoon scene, you might know me from creating live stream overlays for Swimmer Sync and Proving Grounds, but in other titles, I am known for creating broadcast overlays and being the CG operator for LACS Rivals. I've also done projects with Battle of BC and Don't Park on the Grass. In this video, I'm going to give you an overview of the tools and technologies used to create this live stream. This won't be a tutorial on how to make a live stream, but this will show off a lot of tools on how to make one. So if you already make broadcasts, you might find this very useful, or if you're just curious on what it takes to create one, you'll get an idea of the different types of tools and knowledge you need to know to create a live stream like this one. One of the first things I do with a new project is start drafting what overlays may look like in an app called Figma. Figma is a design tool that's really good at creating user interfaces. In Figma, I create concepts of what the live stream may or may not look like. Now keep in mind, these are concepts. This is not actually the tool I use to create the overlays themselves, but this really helps speed up the process with the ability to just mock things up, share it with the team, and get feedback really quickly. You can see here, these are the concepts I've created that decently match what showed up on the final stream. And these were created so I have a reference of what the live stream should look like, and the team has an idea of what the live stream will look like before I commit any time to doing any of the programming regarding that. Figma is also really good at just design in general. All of the social media posts you saw leading up to the event itself were made on Figma. So if you're trying to make really quick, rapid social media posts, Figma is a very good tool to quickly make graphics once you've mastered it. Keep in mind, Figma is a paid tool, but it does have a free tier. If you are a university student, you can get the paid version for free, but the free tier should be fine for most people. With the concepts of the live stream graphics created, it's time to dive into NodeCG. NodeCG is the backbone of this live stream. What NodeCG provides is a server, a web server that contains a dashboard component and a graphics component, whereas the dashboard's controlled by the streamers who can click on buttons, fill out input fields, and such. Think of something like changing the score or changing the team names on stream. They'll be able to control that in the dashboard, which lives in their web browser. Whereas the graphics are also web browser-based sources that live in OBS, which I'll show off in a bit. These graphics are web-based, so that gives them the ability to execute code and run animations and respond to any changes that happen in the server. If you are at all experienced with Node.js or any front-end development, I wholeheartedly suggest you use NodeCG for your live stream. It is very powerful and pretty easy to pick up if you're already familiar with programming. And if you're not familiar with programming, I encourage you to learn it because it's just a good skill to have in general, but maybe I'm a little biased. Next up, this is OBS. OBS is our stream software of choice. This is the program that kind of creates the video feed that you'll see on Twitch or YouTube. OBS is free, open source, and it's very powerful. And there are some alternatives, but honestly, I think OBS is easily the best. And if you're not using it already for your broadcast, you should switch over to it. Within OBS, we have sources. These sources can be stuff like inputs, like audio input, audio output, video capture devices. That could be stuff like capture cards, images, videos, window captures, so you can stream like a window that's on your desktop. For us, we're using a lot of browser sources. Like I said, NodeCG uses browser-based graphics. So the graphic you see here is actually a web page with no background on it. And the benefit for that is if I change some values, like these, like score values got changed or the be right back text got changed, the web page is able to capture that change of information in the server and animate any like changes that happen. The way I code graphics is in Lit. Lit is like a web component framework that is super fast and super lightweight. Something like OBS can have tons of these like browser-based graphics open in the background, so having something super lightweight that uses very little resources in the background it really does make a difference. And you still get the reactiveness of like a traditional web component library such as Vue or React. So if you're using, if you have a broadcast with like a ton of browser sources, I recommend Lit. It's really easy to write in, and it definitely gets the job done while keeping things really fast. For something like this graphic, there's a couple different technologies at play here. For one, I will go over the animations. The animations are using a JavaScript animation library called GSAP. GSAP's really, really powerful. I know there are other animation libraries out there, but I've never had any like feeling to switch because GSAP is so powerful. So if you're trying to animate something in the web or in your live stream, this is a very, very powerful tool, and it's very easy to pick up. So I would recommend using GSAP too. Another part of this graphic is the map itself. The map uses a JavaScript library called Unovis. This is like a data visualization framework for all sorts of like JavaScript like frameworks. It's most known for like its graphs and reactivity and such, but there is a part of it that does maps. And obviously these maps are supposed to be like interactive. In fact, I'm using them a little weirdly in this project, but it certainly gets the job done where I can programmatically just set points on the map and I don't have to think about manually positioning them and such. And in some graphics, such as this one, where we have 2 points connecting one another, Unovis is kind of doing all the heavy lifting here, where I have also made GSAP center the element on screen. When it comes to actually controlling these graphics, each streamer has access to the NodeCG dashboard that I have written. NodeCG provides a nice little tabbed interface here to get to these different tabs, but within each tab is a web page I've created myself. This dashboard is written in Vue. I find Vue very quick and easy to write, but you can use something like vanilla HTML or React or Angular. It's whatever you want. I just personally find Vue the fastest for me. I'm very good at it, so use what's best for you. To speed up development even more, I use a component library called PrimeView. PrimeView provides all the buttons and styling and all the niceties of just being able to quickly make a UI. The benefit of PrimeView is I can just write code and not even think about trying to make the UI work. I don't have to think about making the UI look good or work well. PrimeView just does that part for me. I also use Tailwind CSS to do some really, really fast styling. I'll give a quick tour of the dash. Here's the master panel. This is kind of where I lived during the live stream. It gives me a high-level overview of what's going on each live stream. And then I can also send in next matches to each live stream from here once they have one ready, so the live streamers can just pull that data and they don't have to think about manually entering that info themselves. The database tab contains each team, and if a team's like player name was wrong or anything like that, I can just change it here. Caster data is also done ahead of time, and the map list lives here. Here's the bracket. It's automatically pulled from sendu.inc. There's an auto refresh button that lets it just refresh in the background as progress was made throughout the tournament. Here's a replay tab. Each live streamer has the ability to upload the replays to the NodeCG server. I'll dive a little more into that later. But for our social media person, this is a pretty useful tab where they can see what replays have been uploaded and they can download them to upload them to social media. Here's an individual stream panel. Each streamer, for all 5 streams, had their own variant of this dashboard where they can edit stuff like the break text that appears on the break screen. If they have a next match ready, this will show up. They can edit the current match here. Ink colors are shown here. If the scoreboard's hidden or not, they can change the teams and change the map mode or the score from here. If the streamer has replays, they can do them here. I'll go into more of that later. And they can change casters here with the simple drop-down menu. Something that didn't quite make the final stream, or at least wasn't used in a way that was intended, was our replay system that I've created. The idea was each streamer would upload their replays created in OBS to the NodeCG server. The idea being each stream is able to display their own replays, but also the main stream is able to show the replays created on the side streams. I'll give an example of what that might look like. the workflow would have looked like this. They would go to the Assets tab, add files here, add their clips here, and they would upload. And that part worked well. But the problem is when it came time to play the replays, and as you can see here, they're ready in the dashboard, they're ready to be watched. You can preview them here. The idea was you'd go to OBS and go to the correct scene, and it would stream these replays from the server. Now the problem was, because of all the live look-ins and all the internet usage that was already happening with the live stream, these clips would buffer, and they did not play smoothly during the live look-in portion of the stream, although they did seem to work when that wasn't in play. So at least the clip system got to work near the end of the stream, but for its specific use case of having the side stream replays being played on the main stream, it was a bit of a failure there, but we'll get them next time. For the live look-in section, this was a bit of a mixed bag during the stream. It worked some of the time. I think it worked well enough, but I think it could have been a lot smoother. But I'll show you how it works. We used a tool called Video Ninja. It's like a web-based peer-to-peer video sharing service. So I can invite someone here. If I go here, and when I'm invited, I can join room with a camera. OBS lets you have a virtual webcam that lets you output like a specific scene here. So I have it showing like a dummy capture card here that plays random clips that I have on my computer. When I press start here, it will start streaming the Video Ninja capture here into this scene. And as you can see, I've joined the room. On my screen, I would see this, but each streamer would be streaming their own POV from their live stream. Now for the main stream, they would be able to put this URL that's provided by Video Ninja into this, and then you'd see it would appear inside of the live stream itself through a browser source. Now Video Ninja's default settings kind of prioritize saving bandwidth. As you can see or may not see, I'm not sure what it looks like on your end, but this video feed's a little blurry, a little blocky. So we can do some advanced trickery to kind of improve things. If I paste some of these URL parameters in, I can use a codec called VP9, which is a little more powerful in terms of quality, but it also uses more like CPU power on the streamer's computer. I also set the video bitrate to 9K. That's a very generous bitrate, but I've made sure all streamers are able to support that, so that was a very calculated risk on my part. I also set buffer to 500 milliseconds, so that kind of helps stabilize the video if it kind of needs to buffer for like a split second. If I add these parameters and hit OK, the video is a little clearer. It looks a lot better. When it came time for the actual live stream, there were a couple failures with this approach to the live look-in. One of our streamers had pretty limited upload speed. So what I tried to do was lower the bit rate down to about 4K. And on Video Ninja, you can adjust the resolution down. I've turned the resolution down to maybe like 540p. If you didn't know, bitrate's also dependent on the resolution. So if you're running a lower bitrate, if you lower the resolution, it will kind of negate that effect, that like blockiness effect that a low bitrate causes. That solution worked decently well for that user, but another limitation was another streamer had a less powerful computer, which I thought would still be able to handle the stream fine, but in the end it kind of had some CPU limitations, and their video feed ended up looking pretty blurry. But luckily their actual stream looked fine, so if a viewer really wanted to go watch that stream, they would just be able to go there and watch it perfectly fine. Something to keep in mind. If you're a more advanced streamer, I encourage using CPU encoding. If you're also using Video Ninja, we discovered the hard way. If you're GPU encoding on OBS, Video Ninja also kind of picks up on that and ends up using a very, very heavyweight codec. So I wholeheartedly recommend just CPU encoding if you're going to have a Video Ninja through your virtual cam. As a fun bonus, the casters were also using Video Ninja. Video Ninja is really, really good at just having caster cams on. It's a really good tool for that. So even if you're not doing a total multi-stream, this is a very good, strong use case for webcams for casters. So that's like a surface level look at like the workflow that we had, the tools and technologies used to create this live stream. In the end, I'm decently happy with how the live stream went. I wish the replay system worked a little better, but no one could have really saw that coming. And the live look-ins were a little blurry on some of the streams, but for the most part, they worked decently well. So I'm very happy we tried it. And if we ever do that another time, I think I know a better way to do it. I might try like an RTMP server, or worst case, just have everyone stream to YouTube and have a YouTube stream for each of those clips. But that's kind of like a worst case scenario. If you have any questions, feel free to DM me or message me on whatever platform. If you want to get in touch, a good way to find any of my contact information is jpeg.contact. You can also find some of my past work there if you're interested. But thank you for watching. Thank you for the interest in the stream, the technical side of the stream. I'm very happy to share this stuff. And if you have any questions, feel free to let me know. Thanks for watching.